So this video is going to be a little bit different. I'm not going to go in depth on the code this time. This is just going to be mainly me showing what I've made, and we're just going to take a look at it, watch it evolve for a bit. So what I've made is a genetic algorithm to basically find food and survive, and it's just basically like going to be a sort of a simulation showing how genetic algorithms work. So the first step was not that right there, it was this right here. So just drawing circles on a screen using Pygame, because I'd never used Pygame before, and trying to get them to behave in like a realistic way where they turn with like a physics simulator, like a realistic motion, so you can see they actually slow down and they'll come back. They don't just instantly move towards your mouse, but they gradually turn towards it, so it's quite smooth looking. I hope it comes across properly. I'm recording in 60 FPS, so it should be. But yeah, that was step one, trying to figure that out, and that was hard enough on its own. But yeah, once I got that working, I moved on. So step two was getting them to actually chase food. So food's green, poison's red. Now they chase poison as well, but they die. They have a health value, so you can see the colour gradually changes depending on how healthy they are. Eating food makes them more healthy, eating poison makes them die. Yeah, so you can see they all operate on their own, they all have their own little like ideas of what to do. They can't yet tell the difference between poison and food. All they know is that once they've ate poison they're going to die, or at least they're going to lose a lot of health, and once they eat food they live a bit longer. I've also added boundaries to this one, so they can't just go off the screen. If you see them go off the screen, they should get launched back on. There's like a sort of like, you could think of it as like a magnetic field around the screen to push them back in. It should be like a gradual pushback. So you can see they move quite realistically, like, well, not realistically, but quite gradually. It's quite a nice movement. I was quite impressed with how I'd made it. So yeah, that was the next step. Now I moved on from that, and this is the final product now. So I'm gonna just quickly run through the code. I'm not gonna go through it all, but just I'll outline the key points. So each bot has a colour, which is going to change. It starts out green, but it'll change using this alert function up here, depending on the health of it. As a health, it has a max velocity, it has a max force it can apply. It has a size, it has an age, so this just keeps track of how long it's been alive for. It has DNA, this is the important bit for the genetic algorithm part. Its DNA will be, and this is going to be important in the simulation because I've actually showed this, its DNA is going to be, where is it at? So we should probably look here. So it's got four components to DNA. The first component is how attracted to green are you? Do you want to search for it, in which case it should be a positive value? Do you want to run away from it, in which case it'll be negative? It is possible that they're going to think they've got to run away from green food. You'll see, I'll show you in a sec. So step one, number one, sorry, or DNA entry one. Do you like green? Do you want to go for it? Entry 2, do you like red? Exact same thing but for poison. Entry 3 is what range can you see red from? So you can see their initial perception radius here. This is what range you can see green from, sorry, not red. So the first number, what range can you see green from? Second number, what range can you see red from? So I'm going to show you in a sec what these are when I show the simulation. But basically they have a vision radius around them, and they're going to go to whatever the closest dot is in that range that they are attracted to. So on this initial, this thing I showed you a second ago, they could actually see things that were like 500 units away or something. It might not be in this on this one actually. This one looks more like 100 units or something. But you can see like, for example, if I restart this, actually there's too many dots on the screen now. So this one right here, you see he's just going off on his own, then he saw this, and then he went off and he's now in the same direction until he dies. But you see this one in the same direction, and then he's going to see the green and go for the green. So this is just like the perception radius around them, basically how far they can see. So yeah, that's what their DNA is, them 4 components. That's probably all the important stuff. They have so the genetic part of this, rather than creating a population like I did in the text one, and then generating the new population and killing off the old one, instead what this one does is it'll create like a clone of itself with a really small chance, so it has a reproduction rate, and if it's lived, well, it's not if it's lived for long enough, just every frame it has a chance of cloning itself. Now, if it does manage to clone itself, it's going to copy its own DNA, so it inputs its own DNA, and there is a chance of it being mutated. So you'll see somewhere, not sure where I put this. This is it right here. So mutation rate right here. It can change the DNA slightly. It doesn't change it a lot. It takes the current value and adds this in right here. Yeah, I'll go into this in a second, the simulation, but basically there is a slight mutation rate to it. So yeah, that's how they reproduce, just randomly. Obviously the ones that have lived longer, the idea behind this is the ones that have lived longer is if you live longer you have more time that you could have reproduced in, therefore you'll probably have reproduced more often than someone that doesn't live long, and therefore the good ones, the ones that live longer, will get more chance to reproduce and we'll end up with a healthy population is the idea. What else have we got in here? So we've got, initially we start with 10. We start with 10 completely random bots. They could like green, they could not like green, they could like red, they could not like red, they could see red from really far, they could not see red at all, they could see green from really far, they could not see green at all. It's completely random what the behaviour will be initially, and it'll just evolve. That's the whole idea of this. Now, if there's ever less than one bot on the screen, that's what each of the circles are. That's what they're called. They're called bots. That's what I've called them in this. If there's ever less than one on the screen, it's just going to add one, a completely random one again. There's also a really small chance that we will just add one anyway, no matter how many are on the screen. I did this just so we'd add some sort of random aspect to it. Say if like we end up with a really healthy population, maybe it's not the optimal one, maybe this will find it. I don't know, I thought it'd be interesting to add random ones every now and then. This is really rare, so you probably won't notice this, but it does happen. Now, there's a 0.1 chance of adding food, there's a 0.01 chance of adding poison. I've made it so that there's a maximum number of poison that can be on the screen because I'm not expecting the poison to be it eventually, and I don't want the screen to just get cluttered with loads of poison. And yeah, that's about it. I've also got this print function down here that's just going to help with showing DNA and stuff. It'll print out the oldest ever, what its age was, and it'll print out its DNA. So at the start we're going to get a lot of prints from this because the oldest ever will constantly be changing. But as we get like later on and then the oldest has died and there's not a new one that's taken over, you'll see the prints calm down eventually. So yeah, that's about it. I'm going to run it and I'll talk through what's happening while it's evolving. So here it is. Now it looks a bit different because we've got these circles on, so I'm just going to pause it a sec. Why is it not letting me bring this to the front? Right, there we go. So the green outer circle or inner circle on some of them is its perception radius for food. The red one is its perception radius for poison. Now the green line coming out of it right here, oh, you can't see my mouse. Hopefully you see the green lines coming out of them though, the straight lines. That's how attracted to food they are. Now if that's pointing in the direction they're travelling, then they're attracted to it, and if it's pointing in the opposite direction, they're repelled from it. So you can't tell on this, but when they start moving you'll be able to tell. And red is the same for poison, how attracted or repelled from poison they are. Other than that, that's probably all you need from there. Now in the console you can see a lot of numbers getting printed out. These numbers This number right here is sorry, you're seeing the wrong console right there. Whoops. Can you see? Yeah, you see it now. So this number here is the age, and then this right here is the DNA of that age. So you can see this guy here, he's repelled from green, he's repelled from red. You can see green from 60 units away, and you can see red from 20 units away. So if I had to guess, I'd have to play this to see, but I have a feeling it's... Let's have a look. No, I'm not sure. I'm not sure which one that is. I'd expect he's going to die though, and he did. He did actually die. If we go up here, so this was the guy repelled from green, repelled from red. 60 units, 20 units. He now died because someone else took him over as the oldest. He obviously wasn't going to live. He wasn't eating food, so he just starved to death. There is an element of like their health degrades over time. So if they do nothing, then they die. If they eat poison, then they die. So they have to be constantly searching and eating food. Now the next guy that took over, he was pretty good. He knows to eat food, but he also thinks he can eat poison. So this guy's going to die. He also doesn't see food from very far away. It's only 11 units. I'm not sure if he's still alive. If I can actually see him, is he alive? No, he just died a second ago. So the guy that took over was actually probably, I don't know, but he was probably a child of this guy, because you can see this number is very, very close to this number. So he probably... Actually, no, I take that back. He's probably not a child, because these are the three numbers are all completely different. I would say almost definitely not his child. Or her child, who knows. So yeah, I'm going to let us play out a little bit, and I think it's quite interesting to see what happens. Obviously you can see which ones are attracted where. You can see my mouse now, so yeah, that's handy. So you see this guy, he doesn't like red, he likes green. You can see green from pretty far away, but you can see red from further away. So this guy's probably going to do well. He's probably our oldest one, and in fact he is. He's our only remaining one. And you can see now he's had a child. So if I pause that a sec, we're going to go inspect this child's DNA. So you can see this is the parent right here. This is the parent's DNA and the child's DNA. Now the only difference is the attraction to green. You can see actually the child's worse than the parent, or at least in theory I think he's worse than the parent, because he's not as attracted to green. I would expect that a good example of DNA is really attracted to green, but even more so repelled from red, because it's more important that you don't eat poison than it is to eat food. I expect that you want this number, this 56, to be as high as possible, so you can see food from really far away. So if you are starving and there's no food around you, you can go find it. And I expect that the poison number, the vision for poison, should be pretty low, but not so low that you're accidentally going to eat it. But if this number's too high, I expect that you're going to be pushed away from food a lot. So I would expect that you need a big green ring, a medium-sized red ring, really repelled from red, and quite attracted to green, but not overly, because you want to be able to be pushed away from the green if there's a red right next to it. I expect that is how the optimal one is anyway, but we'll see. We'll see what it gets to. It should, in theory, find the optimal one on its own. I guess we'll see. So I'm not sure how long this is going to take before it actually finds pretty optimal stuff, but I guess we'll see. You can see actually the parent died. This is the child now that's alive, and the child's just had two children that immediately died. So if I just pause that a sec, you can see here, I'm not sure why he's still going, but you can see here the children that it had. They actually were really attracted to red, so no wonder they immediately died. Both children were really attracted to red. I'm not sure why it spawned two with the exact same numbers here, except for the green radius. That might be some bug in the code or something, but either way, you saw that they were attracted to red and they didn't survive very long. What I'm going to do here, just to speed things up, is I only had initially the max of 1. I had the max of 1 just to show the one guy initially, and we could like monitor the behavior. Originally I had this as 5. There was a maximum of 5 bots on the screen. So yeah, I'm just gonna do that. It'll save us having to watch one and let this one mutate forever. So yeah, this guy here is doing okay, but he's not too aware of poison, so this guy's probably going to get accidentally poisoned at some point because he's not aware of where poison is. He can't see it from very far away. We can keep watching him, but I suspect he's going to run into poison accidentally. He's doing pretty well so far, like. I actually think he's our oldest one. In fact, I'm pretty certain he is. If you look at the DNA of the oldest one over here, with only a 6 radius for detecting red, that is probably him. Yeah, here we go. He's probably going to hit poison very soon. Nope. Dodged it. He's actually doing surprisingly well. I thought he'd have died by now. There we go. So you saw there why it's important to be more repelled from green, more repelled from red than it is green. He actually did hit the poison, but he's lucky that he had a lot of life. He's had a lot of food, so he could take the hit. They actually lose 80% of their max health if they hit a poison. So you see, he died there. I think just one spawned in front of him or something. But yeah, so you can see a lot of these have actually got very similar DNA just from looking at them. The rings are all very similar size, and their attraction and repulsion to the food and the poison is very similar. So this could be getting close to a balance, sort of. This guy here, I reckon, is going to do very well. You can see he's really repelled from red, and he can see red from quite far away, but he can see green from even further away. I have a feeling this guy is going to live a very long time, except he just instantly died, so there goes that theory. I think there's a slight problem with how I spawn in the poison as well. I have a feeling that random spawns of poison just like spawn in front of things that don't get time to react and turn around. I think that's kind of ruining some of them. But yeah, you can see we've currently got a pretty good one. He's lived to 5,600 so far. Not sure which one it is, but maybe this one down here. I think it might be this one. Them two circles look about 12 units different, something like that. So yeah, I thought it was quite interesting. Hopefully you find it interesting. If you're interested in the source code, let me know. I can post it. And yeah, that's going to be it from me. I'll leave this running another couple of minutes in case anyone's interested, wants to see it. But yeah, that's going to be it from me. If you like the video, leave a like. If you want to see more stuff like this, then subscribe. I've got other plans for a couple of other Python stuff I want to do in future. Maybe another few things involving genetic algorithms, or I wouldn't mind taking a look at some neural networks or something, but I can't think of anything too good to do with them. I've never done them before, I've never used one before, so I'm not too sure what can and can't be done. And I'm still really learning Python myself, so yeah, I'll see what I get around to. But if you want to see more, subscribe, and if you like the video, like it. And that's it for me, so thanks for watching. I'll see you on the next one.